Welcome to Pen and Paper Programming. We are going through problems in Elements of Programming Interviews book in Chapter 4, Primitive Types, and we are going through the variant questions. This is variant question number 2. We have the same constraints, write expressions that use bitwise operators, equality checks, and Boolean operators to do the following in constant time. So the second question is compute x mod a power of 2. What that means is 77 modded with 64, which is 2 to the 6, which will give you a remainder of 13. So when we go through this type of questions, it is really important to write down some examples. They're already giving us an example. So if you have 77, this is the binary representation, and the 64, which is the mod that we are taking, then this is the binary representation of that number. So when you look at these binary numbers, I think hopefully one thing that jumps out at you is the fact that 13 here is at 1, 0, 1, 1. That's 1, 2, 4, 8. 8 plus 4 is 12 plus 1, 13. So this component, this part here is your remainder, right? And at the end, if you want to get the result of 13, that's the part of that binary number that you're trying to isolate. And how could we do that? So another hopefully thing that jumps at you here is that this most significant bit here, which is the 1, 2, 3, 4, 5, 6, 7th bit, is the one that you want to erase to get the number 13. I mean the decimal 13, the least four significant bits here, right? So question becomes, how do you erase this bit and keep these last 4 bits? If we can achieve that, then that means we can actually get the remainder easily in constant time. So one way that I can see that we can do it is by having this number here, which is basically having a number where this seventh bit is 0 and the remainder bits on the right hand side of it is 1. And if I can get a number easily that way, and if I end that number with my original number, which is 77, I will erase the most significant bit and keep the rest of it. What I mean is, so in this case we have 64. If I somehow get this bit to 0 and the remainder bits to be 1, by the way this is 63, then I can get rid of the most significant bit. This will become 0, and then I will keep the everything else as the same. So as I said, if you subtract 1 from 64, that becomes 63. So if you AND these two numbers, if you apply AND operation to these two numbers, what you will end up is 1, 0 and 1 is 0, 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, and in this case 1 and 0 is 0. Wow, we got 13. So this is 13. So how could we generalize that? So let's write a function, define a mod power 2, which will take a number and a power. So power, let's say in this case, let's say that we are past 77 and power 6. 6 is 64, and 2 to the 6 is 64, and we have our number is 77. So if I take 1 and left shift that by 6, what I get? I get 64. And if I subtract 1 from it, I get 63, which is this number here, right? And 63. If I end it with my original number, what I get? I get 13. I'm sorry, here we go. Let me just show that. So our result is basically take x, end it with 1 left shifted by number of times the power minus 1. So this will give us, this component here will give us the 63 ended with 77, which will get us 13. So going back, it's important to write down the examples and see the pattern, what you need to do, and find bitwise operators to be able to accomplish what you're trying to accomplish. I hope this makes sense. If it doesn't, leave a comment.